Students, in last class we learned how to balance a chemical equation. We will take one more example of this so that you can understand perfectly how to balance a chemical equation. This time we are discussing the preparation of ammonia gas. When nitrogen gas reacts with hydrogen gas, it forms ammonia, NH3. All the three are in gaseous state. As we discussed, students, in the first step, the dash you can see are the places where you will put number in order to balance a chemical equation. Now counting the number of atoms on left and right hand side, you can see here we are having 2 atoms of nitrogen and here just 1. And we are having 2 atoms of hydrogen on left hand side, while on right hand side we are having 3 atoms of hydrogen. So you can take any one of them. Starting from nitrogen, we have placed a 2 in front of it in order to balance the nitrogen. Now student, when 2 multiplies 3, you will get answer 6. It means on the right hand side you are having 6 hydrogen atom. In order to balance the hydrogen on left hand side, you have to place another 3 so that your reaction can be balanced. Now your reaction N2 plus 3H2 gives 2NH3 is balanced, and as we have discussed, we have to place the states. That is why I have placed G along with these formula of the reactants. Now we will discuss the type of chemical reaction. Students, majorly the chemical reaction are divided into 5 types, which are combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and lastly, redox reaction. We will explore more about the combination reaction. A reaction in which 2 or more substances combine together to form a single product. Such a reaction is called combination reaction. Moving to the example, the first example is of slaking of lime. When you add water to quicklime, it forms slaked lime along with a huge amount of heat. This is the same lime which we use for whitewashing purpose. Students, we have to know something more about it. A solution of slaked lime produced in the above reaction is used for whitewashing walls. Calcium hydroxide reacts slowly with carbon dioxide in air to form a thin layer of calcium carbonate on the wall. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. So students, the formula of calcium carbonate is CaCO3. Now we will have a look on the reaction which occurs when carbon dioxide reacts with your slaked lime. Slaked lime is CaOH whole twice. When it reacts with CO2, it forms CaCO3 plus water. Now moving to the next example, it is burning of coal. Coal is represented by symbol C because it has carbon. When carbon burns in air, which means with oxygen, it forms carbon dioxide along with heat. Next, formation of water. Water is formed when hydrogen gas and oxygen gas react with each other in presence of electricity. So these were the example of combination reaction. Here you can see that in every reaction, either 2 or more reactants react together to form just one product. That is why all these reactions were of combination type. Students, such a reaction in which heat is released along with the formation of product are called exothermic reaction. Some combination reaction are exothermic in nature. As when we were discussing the slaking of lime, I told you that in this reaction, heat evolves along with formation of product. Similarly, here when you burn coal, you get heat along with carbon dioxide. So we can say that some of the combination reaction are exothermic. Now we will explore more example of exothermic reactions. The first example is burning of natural gas. Natural gas is methane and its formula is CH4. When methane burns with oxygen, it forms carbon dioxide and water. I have written balanced chemical equation for you. The next example is of respiration. Students, respiration process occurs when we take oxygen and our digested food, glucose, break down in order to give energy and other products. So the reaction is C6H12O6 plus 6O2 gives 6CO2 plus 6H2O along with energy, which is in the form of ATP. Now, last example is decomposition of vegetable matter into compost. Our next reaction is decomposition reaction. A reaction in which a single reactant breaks down to form two or more products by taking energy in the form of heat, electricity, or sunlight is called decomposition reaction. Students, one thing you have to keep in mind that your decomposition reaction is just opposite of combination reaction. Let me remind you. In combination reaction, you studied that two or more reactant combines together to form a single product. And here, a single reactant breakdowns in order to form two or more products. Decomposition reaction has been divided into three types as per the requirement of energy in each of them. When decomposition reaction occur in presence of heat, then we say thermal decomposition. When decomposition reaction occur in presence of electricity, we say it electrolysis. And when your decomposition reaction occurs in presence of sunlight, it is photolysis. So we will see each of them. First, thermal decomposition. As I said, student, thermal decomposition is a reaction which occur in presence of heat. Your first example is ferrous sulfate. When we heat ferrous sulfate crystals, students, these ferrous sulfate crystals are green in color. When you heat these crystals, then you get ferric oxide, which is brown in color, and you also get SO2 and SO3. In this reaction, the SO2, sulfur dioxide and sulfur trioxide, has a characteristic smell of burning sulfur. Characteristic smell of burning sulfur. So student, these observations are important for you. You must write these things in your notebooks. Moving ahead. When limestone is heated, calcium carbonate, which is called limestone, when it heated, it gives quicklime, CaO and carbon dioxide gas. Moving to the next example. This is of lead nitrate. When lead nitrate is heated, then it gives lead oxide, nitrogen dioxide and oxygen. One thing we have to notice, which is this NO2 gas, this nitrogen dioxide gas, it is brown in color. When you will heat this compound in a test tube, then you will see a brown colored gas coming out of the test tube, which will be nitrogen dioxide. Okay, students. The next decomposition type is electrolysis. Electrolysis is that decomposition which occur in presence of electricity. Here we are taking example of electrolysis of water. When we have to do electrolysis of water, then we need a container in which there will be two electrodes, cathode and anode. Students, you have to keep one thing in mind. You have studied what are cations and anions. As you know, cations are positive. So you have to keep in mind that this cathode is negative. And similarly, as you know, anions are negatively charged ions. So you can relate that your anode is positive in charge. Now moving ahead, students, When we have to do electrolysis of water, then we have to add a small amount of sulfuric acid H2SO4 to it. This H2SO sulfuric acid increases the conductivity of the solution and makes the decomposition process easier. Students, in this process, hydrogen gas release over cathode while oxygen gas release over anode. One thing which we notice here is the amount of hydrogen gas is double to that of the oxygen. The reason for this is, look students, when water decomposes, it forms 2 mole of hydrogen gas and single of oxygen. In easier language, you can say that when 2 molecules of water decompose, then it forms 2 molecules of hydrogen gas and only 1 molecule of oxygen gas. This is the reason that the amount of hydrogen gas is double to the amount of oxygen gas. The third type of decomposition is photolysis. This decomposition occurs in presence of sunlight. There are few compounds like silver chloride and silver bromide which undergo such kind of reaction. Here in this diagram you can see, student, silver chloride has been placed in sunlight, and after some time this white colored silver chloride will turn to grey color after the reaction. The reaction is 2AgCl gives 2Ag plus Cl2. Moving ahead, another example is of silver bromide. When silver bromide is kept in sunlight, it also forms silver plus bromine gas. These reactions are used in black and white photography. Now, the reaction in which energy is absorbed are known as endothermic reactions. And thus, students, all the decomposition reaction are endothermic in nature because every decomposition reaction requires some amount of energy to occur. That energy can be provided either in the form of heat, light, or electricity. That's all, students.